What if the map of your world, the one you have known your entire life, was wrong? Not just inaccurate, but fundamentally incomplete, missing a continent so vast it makes all the others seem like scattered islands. For centuries we have sketched our cosmic address with a confident hand, a planet circling a star nestled in the Orion arm of a spiral galaxy called the Milky Way. This was home, a glowing metropolis of 200 billion suns, immense and magnificent, a seemingly complete universe in itself. But this confident cartography, this cherished sense of place, is an illusion. It is the charming provincial drawing of a child who has never left their own valley. We have been living on the shores of an ocean, believing it to be a mere pond. Our journey tonight is not one of discovery, but of rediscovery, of tearing up the old maps to reveal a structure of such incomprehensible scale that its existence was hidden in plain sight, written in the subtle motion of every galaxy we could see. We are about to chart the true boundaries of home, a domain not of light but of gravity, an invisible empire whose gravitational heart beats hundreds of millions of light years away. You think you live in the Milky Way, but the truth is far grander, far stranger, and infinitely more profound. The Milky Way lives inside Laniakea, and its name, whispered from ancient Polynesian navigators, means Immeasurable Heaven. Our journey begins with a departure, a silent slipping of the bonds that tie us to the familiar. We pull away from the warm blue-white marble of Earth, watching continents and oceans resolve into abstract swirls of colour, the signature of our biosphere shrinking to a fragile jewel. The moon, our constant companion and celestial anchor, becomes a pockmarked pebble, its orbital dance a delicate pirouette around a world now small enough to cover with your thumb. We accelerate past the rusty glow of Mars, a sleeping world, dreaming of ancient rivers, and plunge into the majestic chaos of the asteroid belt, a ghostly graveyard of planetary ambitions where countless shards of rock and ice tumble in a silent cosmic ballet. Jupiter, the colossal king, looms before us, a churning maelstrom of gas and storm so vast that all other planets could be swallowed by its great red spot, a hurricane that has raged for centuries. Its powerful gravitational field, a miniature solar system in its own right, slingshots us deeper past the exquisite icy rings of Saturn, a celestial work of art hanging in the velvet blackness. We race by the pale tilted spheres of Uranus and Neptune, lonely sentinels in the frigid outer darkness, their methane atmospheres absorbing the faint distant sunlight. Finally, we cross the orbit of Pluto, the demoted prince of our solar system, and breach the final frontier of our sun's immediate kingdom. Here at the edge of the Kuiper belt, the sunlight is 1,000 times dimmer than on Earth, a twilight that offers little warmth. Our star is just the brightest point of light in a sea of countless others, yet we are still not free. For another light year, a journey that would take a modern spacecraft tens of thousands of years, we are still swimming within the sun's gravitational tide. We are pushing through the Oort cloud, a theoretical spherical shell of trillions of icy bodies, the frozen remnants of our solar system's birth. This is the sun's final ghostly whisper, the last tendril of its influence. Every comet that graces our night sky is a visitor from this dark, silent realm, a messenger from the absolute edge of home as we once defined it. But as we finally break through this last veil, the true scale of our galactic residence begins to dawn. The sun shrinks, joining the chorus of its stellar brethren. Before us, the Milky Way unfolds, not as the gentle, hazy band we see from our backyards, but as the staggering dynamic structure it truly is. We are inside a colossal spinning disk of stars, gas and dust, a spiral-armed empire 100,000 light-years across. From our vantage point within the Orion arm, about 2/3 of the way from the centre, we can see the grand design. Rivers of dark dust, the birthplaces of future stars, snake through glowing nebulae, where celestial blowtorches of newly formed massive suns carve out vast cavities in the interstellar medium. Clusters of ancient golden stars orbit in the galaxy's halo, a spherical swarm of cosmic elders that witnessed the Milky Way's violent formation over 12 billion years ago. And at its heart, a place of terrible beauty, lies the galactic core. It is a dense, elongated bar of old reddish stars, a furiously bright spindle at the centre of the spinning pinwheel. Here, stars are packed together millions of times more densely than in our quiet neighbourhood. and at the very centre of this stellar chaos, veiled from our eyes by impenetrable clouds of dust and gas, lurks Sagittarius A, a supermassive black hole 4 million times the mass of our Sun. It is the galaxy's gravitational dynamo, the silent, invisible monarch around which this entire city of light revolves. For billions of years, our Sun and our world with it has been locked in a stately 230 million year orbit around this distant, monstrous heart. This vast, intricate and dangerous place, this island universe, has long been our ultimate definition of home. It is our nation, our continent, our world, all rolled into one. Surely this must be the end of the map, but it isn't. As our perspective continues to expand, a startling new reality emerges. The Milky Way, our grand and glorious home, is not alone. It is merely one of the dominant members of a small, intimate cluster of galaxies, a celestial archipelago known as the local group. This is the next layer of our cosmic address, our galactic neighbourhood. Stretching across 10 million light-years of intergalactic space, this is our family. The undisputed matriarch of this clan is Andromeda, a magnificent spiral galaxy even larger than our own. Visible to the naked eye as a faint fuzzy smudge in the autumn sky, it is our cosmic sibling, our celestial twin. In the unimaginable darkness between us and Andromeda, smaller dwarf galaxies are scattered like forgotten children orbiting their larger parents. The large and small Magellanic Clouds, visible only from the southern hemisphere, are our own chaotic, irregular satellites slowly being torn apart by the Milky Way's immense gravity. The Triangulum Galaxy, the third largest member, hangs nearby, a beautiful face-on spiral. Dozens of other fainter dwarf galaxies complete the census, all bound together by their mutual gravitational attraction, forever falling towards a common centre of mass. For decades, astronomers believed this was the fundamental structure that defined our place. We were citizens of the Milky Way, which was a member of the local group, an isolated and self-contained family of galaxies drifting through the endless void. But a disturbing observation, a cosmic anomaly, began to unravel this tidy picture. When we measured the motion of the local group, we found something deeply perplexing. It wasn't just drifting, it was moving, and not randomly. Our entire galactic family, the Milky Way, Andromeda, and all their satellites are hurtling through intergalactic space at a staggering speed over 600 kilometers per second. That is more than 2 million kilometers per hour. This was a profound mystery. An object in motion stays in motion, but something had to have set us on this trajectory in the first place. What could possibly exert a gravitational pull so immense that it could command the movement of an entire cluster of galaxies across millions of light-years? The combined mass of the local group itself was not nearly enough to account for this incredible velocity. It was as if our entire archipelago of light was being swept along by an invisible, powerful current in the cosmic ocean, a current whose source was nowhere to be seen. The search was on for the origin of this peculiar velocity, this unexplained cosmic hurry. Astronomers began to meticulously map the positions and motions of galaxies far beyond our own local group, searching for a massive concentration of matter, a gravitational anomaly that could be the culprit. They were acting as celestial detectives looking for the fingerprints of a phantom. The clues pointed in the direction of the constellations Hydra and Centaurus. In that sector of the sky, galaxies seemed to be streaming away from us more slowly than they should be, as if they were being held back by an immense gravitational leash. Farther out, galaxies were moving towards this same region. It was a cosmic convergence, a focal point for galactic motion over an enormous volume of space. Scientists had discovered a cosmic giant hiding in the shadows. They named it the Great Attractor. This was not a single object, but a diffuse, sprawling concentration of mass equivalent to tens of thousands of Milky Way galaxies lurking some 150 million light-years away. It was shrouded from direct view by the dense dust and stars of our own galaxy's planar region, appropriately named the Zone of Avoidance. We were being relentlessly pulled toward this unseen behemoth, a gravitational monster dragging our local group and thousands of other galaxies along with it. The mystery, it seemed, was solved. Our cosmic map had a new dominant landmark. But the solution was not so simple. As our surveys of the universe became more sophisticated, our measurements more precise, the numbers still didn't quite add up. The Great Attractor was massive, certainly, but it alone could not fully account for the tremendous speed of our local group. Even its immense gravitational handshake wasn't strong enough. The invisible current was even wider, even more powerful than we had imagined. The true source of our motion had to be something far larger, a structure so gargantuan that the Great Attractor itself was merely a component, a single gravitational valley in a continent-spanning mountain range. It was this realization that shattered our cosmic worldview forever. The problem was a matter of perspective. We had been trying to map a watershed by standing in the middle of one of its rivers. We couldn't see the full extent of the basin because we were inside it. A team of astronomers led by Brent Tully at the University of Hawaii decided to approach the problem in a revolutionary new way. Instead of just looking at where galaxies were, they focused on how they were moving. They compiled a massive catalogue of the peculiar velocities of thousands of galaxies in our cosmic vicinity. Each galaxy's motion stripped of the overall expansion of the universe was a vector, an arrow pointing in the direction of the dominant gravitational pull it felt. When they mapped these vectors, an astonishing picture emerged. It was a map not of matter, but of motion, a map of flow. What they saw were cosmic rivers of galaxies all streaming towards common basins of attraction and away from vast empty voids. They had uncovered the hidden circulatory system of the local universe, and at the centre of this breathtakingly complex network of gravitational tributaries, they found the heart. The Great Attractor was not the ultimate destination. It was merely the central drainage point, the lowest elevation, in an immense gravitational basin that contained our own Milky Way and 100,000 other galaxies. This finally was the true extent of home. This was the continent that had been missing from our maps. They gave it a name befitting its scale drawing from the Hawaiian language, in honour of their location, a culture of master navigators who charted the vast Pacific by observing the subtle currents and stars. They called it Laniakea, Immeasurable Heaven. It is a name that perfectly captures the sublime nature of the discovery. Laniakea is not a thing in the traditional sense. You cannot point a telescope at it and see its edges. Its boundaries are not defined by light but by flow. It is a domain of gravitational influence. Imagine all the rainwater that falls on a continent. Every drop, every streamlet, every river will eventually flow into a single great ocean basin. That entire region of land is the river's watershed. Laniakea is a cosmic watershed. Every one of the 100,000 galaxies within its borders, including our own, is gravitationally bound to it, flowing downhill toward the central basin of the Great Attractor. A galaxy just outside its invisible boundaries on the other side of the cosmic continental divide. Its motion will carry it towards a different supercluster into a completely different gravitational ocean. Our Milky Way is not an isolated island universe. It is a single drop of rain in this immeasurable basin. For the first time, we have a meaningful, physically defined address on the largest of scales. We are residents of Earth in the solar system, within the Orion arm of the Milky Way galaxy, a member of the local group, which is an outlying province of the Virgo cluster, all of which is just one small part of the Laniakea supercluster. This structure is 520 million light-years across. It contains the mass of 100 quadrillion suns. Light itself takes 500 million years to traverse its full expanse, and yet this entire celestial continent, this immeasurable heaven, is itself in motion, part of an even grander cosmic dance. The mapping of Laniakea also revealed the other side of the equation. To create such a powerful flow, you need not only a great basin to pull everything in, but also a great mountain to push everything away. The data revealed a massive region of space, largely empty of galaxies, a cosmic void sitting adjacent to our supercluster. This void, which they named the dipole repeller, actively pushes us away, its lack of mass creating a gravitational high ground from which we and our neighbours are effectively fleeing. Our incredible velocity through the cosmos is therefore a combination of two colossal forces, the gravitational pull of the Great Attractor ahead of us, and the gravitational push of the dipole repeller behind us. We are caught in a cosmic tide, a push and pull, on a scale that defies human comprehension. This is the new cartography, a universe not of static objects, but of dynamic flows and invisible architectures. The quest to understand our place has led us here to the shores of this newfound continent, a home so vast we're only now beginning to chart its coastlines. We're no longer just stargazers. We have become galactic oceanographers studying the currents and tides that shape the universe itself. The story of Laniakea is the story of our final liberation from a limited Earth-centric view. It is the ultimate recognition that we are part of a connected, dynamic, and ever-evolving cosmic web. Our journey has just begun. Now we must venture into the heart of this immeasurable heaven, to explore its great clusters, to understand the ghostly dark matter that provides its gravitational scaffolding, and to seek the ultimate fate of 100,000 galaxies, all flowing as one towards a destiny millions of light years away. We must map the unseen, and in doing so finally and truly find our place in the cosmos. What is our true address in the cosmos? The question seems simple, a matter of orientation, of finding our specific place on a grand celestial map. For nearly all of human history, the answer was profoundly intimate. We were the centre, the entire point of the exercise. The universe was a bespoke creation, a celestial dome pricked with points of light, a canopy of crystal spheres turning in perfect divine harmony around us. This was a map born of the naked eye and the human heart's desire for significance, a chart drawn on the parchment of the night sky, where constellations told stories of gods and heroes and wandering lights. The planets were omens and messengers. This map was comforting, it was finite, and it placed humanity at the very heart of creation. Every star, every faint smudge of light was believed to be a feature within our own stellar home, a local phenomenon. The universe was for all intents and purposes our galaxy. This geocentric model perfected by Ptolemy was not merely a scientific theory, it was a philosophical anchor, a worldview that lasted for over 1,500 years. It was a masterpiece of observation and mathematics built on a beautifully flawed premise. It gave us a sense of order in what could otherwise feel like an infinite, terrifying void. But maps by their very nature are destined to be redrawn. They are sketches of our current ignorance waiting for a new discovery to tear them up and demand a bolder, more expansive replacement. The tearing began not with a grand gesture, but with the quiet polishing of a lens. When Galileo Galilei first pointed his crude telescope towards the heavens, he wasn't just looking at the sky. He was aiming a dagger at the heart of the old world. What he saw began the systematic dismantling of our cosy Earth-centered map. He witnessed moons orbiting Jupiter, proving that not everything revolved around the Earth. He saw the phases of Venus, a celestial dance that could only be explained if it orbited the Sun. Most poignantly, he looked at the Milky Way, that ethereal river of light known to every culture on Earth, and resolved it into what it truly was, an impossible, uncountable multitude of individual stars. Our Sun was not special. It was just one among a sea of distant suns. The celestial dome was shattered, replaced by a terrifying and exhilarating sense of depth. Yet even in this radical new vision of a sun-centered system adrift in a galaxy of countless stars, one comforting notion remained. Our galaxy, the Milky Way, was still considered the entirety of the universe. It was a single, magnificent island of stars floating alone in an endless, empty ocean of cosmic night. The faint, fuzzy patches of light that astronomers had long catalogued the nebulae were thought to be celestial clouds within our own galactic borders, perhaps the birthing grounds of new solar systems. They were local curiosities, footnotes on the map of our island universe. This was the prevailing wisdom at the dawn of the 20th century. But a profound debate was simmering at intellectual conflict that would determine the true scale of reality. On one side was Harlow Shapley, a brilliant astronomer who had accurately mapped the vast dimensions of the Milky Way, correctly placing our Sun in its suburbs rather than its centre. He argued forcefully that our galaxy was the whole show, that these spiral nebulae were mere gas clouds nearby. On the other side stood Heber Curtis, who contended that these smudges were something far more profound, island universes, entire galaxies just like our own lying at unfathomable distances. The great debate, as it became known, was a clash over the very meaning of the word universe. Was it one island or an archipelago of infinite islands? The question would be settled on a mountain in California, under the gaze of the largest telescope the world had ever seen. There, Edwin Hubble, a meticulous and relentless observer, spent night after freezing night at the Mount Wilson Observatory, capturing the light of the Andromeda Nebula on immense glass photographic plates. He was hunting for a specific type of star, a cosmic yardstick known as a Cepheid variable. These remarkable stars pulse with a rhythm that is directly related to their true brightness. By comparing their apparent dimness with their known intrinsic luminosity, Hubble could calculate their distance with unprecedented accuracy. He found a Cepheid within Andromeda. He checked his calculations. He checked them again. The numbers were stark, unambiguous, and universe-shattering. The light from that single pulsating star had travelled for nearly 1 million years to reach his telescope. Andromeda was not a cloud of gas within our galaxy. It was a sister galaxy, a sprawling metropolis of hundreds of billions of stars lying far beyond the most distant shores of the Milky Way. In that moment, the known universe did not just expand, it exploded. Our cosmic map was torn to shreds once more. We were not on a solitary island, we were part of a cosmic archipelago of staggering proportions, a universe populated by billions, perhaps hundreds of billions of other galaxies each. A pinwheel of light containing its own countless suns and worlds. The fuzzy nebulae were revealed for what they were, distant galactic continents separated by gulfs of intergalactic space so vast they defied comprehension. For the first time we had a glimpse of the true framework of the cosmos. The fundamental building blocks were not stars but galaxies. A new era of cosmic cartography had begun, and the first task was to map our immediate galactic neighbourhood. What we found was that we were not alone at all. Just as planets orbit a star and stars orbit the centre of a galaxy, it turned out that galaxies themselves are bound by gravity's relentless invisible tether. As astronomers surveyed the skies, they found that the Milky Way was not an isolated entity. We are part of a small, gravitationally entwined collection of galaxies, a cosmic family known as the Local Group. The undisputed sovereign of this group is the magnificent Andromeda Galaxy, our slightly larger twin visible to the naked eye as a faint ghostly smudge in the autumn sky. It is hurtling towards us at over 100 kilometers per second, destined for a titanic, majestic collision. In about 4.5 billion years, a gravitational dance that will see our two galaxies merge into one colossal new entity. Circling these two giants are dozens of smaller dwarf galaxies like celestial pilotfish accompanying cosmic sharks. These are the forgotten members of our local family, faint wispy collections of stars like the large and small Magellanic Clouds, visible only from the southern hemisphere. They are our constant companions bound to the Milky Way by immense invisible streams of gas and stars slowly being shredded and consumed by our galaxy's much larger gravitational field. This was the next refinement of our address, the Milky Way Galaxy Local Group. We lived in a quiet, sparsely populated galactic suburb. For decades, this map seemed largely complete. We understood the local dynamics, the gravitational pull and sway of our immediate neighbours. But the cartographers of the cosmos, driven by an insatiable curiosity, kept pushing the boundaries of their surveys, peering deeper into the void. They began to notice that even groups like ours were not randomly distributed. There was a larger pattern, a grander architecture at play. As they mapped the positions of thousands upon thousands of galaxies, a colossal structure began to emerge from the darkness. It was a sprawling filamentary superstructure, a gargantuan conglomeration of galactic groups and clusters all loosely bound together. At its heart lay a monster. This was the Virgo cluster, a teeming chaotic city of galaxies located some 50 million light-years away. Unlike our placid local group, the Virgo cluster is a violent dynamic environment, a cosmic metropolis where over 1,000 galaxies are packed together in a relatively small volume of space. Here galaxies collide and merge frequently, their graceful spiral arms torn asunder by gravitational tides. At its core sits Messier 87, a gigantic elliptical galaxy, a cosmic behemoth that has grown to its immense size by cannibalizing its smaller neighbors. A supermassive black hole billions of times the mass of our sun lurks in its center, spewing a brilliant jet of plasma thousands of light-years into intergalactic space. And we and our quiet local group were not separate from this chaos. We were on its outermost fringe, an insignificant suburb gravitationally tethered to this vast galactic empire. This entire structure, the Virgo cluster and all the surrounding groups, including our own, became known as the Virgo Supercluster. For a generation of astronomers, this was the pinnacle of cosmic structure. Our address was finalised Earth Solar System Milky Way Local Group Virgo Supercluster. This was thought to be the largest gravitationally coherent entity in the universe, a celestial continent 100 million light-years across. Beyond it, we assumed the universe became a uniform tapestry with superclusters spread out more or less evenly, all participating in the smooth, elegant expansion of space itself as predicted by Hubble's law. This law is the golden rule of cosmology. It states that due to the expansion of the universe, every distant galaxy is receding from us. The farther away a galaxy is, the faster it appears to be moving away. It's a simple, predictable cosmic flow, like the surface of an expanding balloon. Once you accounted for this universal expansion, and the small local gravitational tugs within the Virgo supercluster, the movements of galaxies should have been straightforward. They should have been orderly, but they weren't. When astronomers in the 1970s and 80s began making exquisitely precise measurements of galaxy motions, they stumbled upon a deep and disturbing anomaly. They found something that shouldn't be there, a ghost in the machine. After subtracting the motion from the expansion of the universe, and after subtracting the gravitational pull of all the visible galaxies in the Virgo supercluster, there was still a huge unexplained residual motion. It wasn't random. It was a coherent bulk flow. Our local group, the Virgo cluster, and every galaxy in our vast cosmic neighbourhood, spanning hundreds of millions of light-years, were all being dragged in the same direction, like driftwood caught in a powerful unseen current. We were streaming across the universe at a staggering 600 kilometers per second, over 2 million kilometers per hour towards a specific point in the sky, in the direction of the constellation Centaurus and Hydra. This collective anomalous motion was christened the Dark Flow. The name itself evokes the profound mystery it represents. It was a violation of the cosmological principle, the assumption that the universe is the same in all directions on large scales. It suggested our map was not just incomplete, it was fundamentally wrong. The Virgo supercluster, which we had crowned as the largest structure in our cosmic vicinity, was clearly not the final word. It could not possibly contain enough mass, enough gravitational authority to command such a vast and rapid flow. Something else was out there. Something immense hidden beyond our sight was exerting an astonishing gravitational pull across a colossal swathe of the universe, overriding the cosmic expansion and yanking tens of thousands of galaxies, including our own, towards an unknown fate. The implications were breathtaking. We were like passengers on a ship feeling a powerful, inexorable pull, but seeing nothing on the horizon responsible for it. The charts we had so painstakingly drawn, from the star maps of ancient Babylon to the galactic surveys of the 20th century, were all missing a key feature. A gravitational continent of unimaginable proportions was lurking just over the cosmic horizon, its existence betrayed only by the massive wake it created in the river of space-time. The discovery of the dark flow was the moment our understanding of our place in the universe began to unravel once more. It was the ultimate cartographic challenge, a signpost pointing into the darkness, indicating the presence of a structure so vast, so massive, that it had remained completely invisible to us. The search for the source of this pull for the Great Attractor, as it was sometimes called, would lead us to redraw our cosmic map on a scale we had never before dared to imagine, revealing an immeasurable structure that we now finally are beginning to call home. For a time, our cosmic maps were things of exquisite beauty yet profound deception. They were grand tapestries woven from pinpricks of light, each point a galaxy of 100 billion suns. On these flat two-dimensional charts, we had plotted the heavens, organising the chaotic spray of creation into familiar shapes, christening clusters like Virgo and Fornax. It was a monumental achievement, a testament to our relentless drive to impose order upon the universe. Yet with every new galaxy added a deep and unsettling inadequacy, grew within the astronomical community. These maps were fundamentally dishonest. They were like trying to understand the intricate geography of a mountain range by looking at a single photograph taken from a great distance. You see the peaks, you see their arrangement across the landscape, but you have no concept of their staggering height, their terrifying depth, or the hidden valleys that connect them. Our celestial charts showed us the where in the sky, but they were utterly silent about the how far. They lacked perspective, the crucial third dimension. Without depth, every galaxy was a neighbour, every cluster and island adrift in an archipelago of unknown scale. The universe we saw was a projection, a celestial fresco painted on the dome of night. And this flatness fostered a beautifully simple, but ultimately flawed idea of cosmic structure. We imagined a hierarchy and elegant cosmic ladder. Planets orbited stars, stars formed galaxies, galaxies gathered into clusters, and clusters we assumed were the top of the rung, the great metropolises of the cosmos separated by vast, uninteresting emptiness. They were thought to be gravitationally bound islands, each a serene kingdom unto itself, drifting sedately apart as the universe expanded. This was the established view, a comfortable and orderly model that fit the data we had. But science thrives on the anomalies, on the nagging feeling that the map doesn't match the territory. The quiet assumption that galaxies were scattered through space with a kind of uniform randomness began to feel less like a law of nature and more like a failure of our own perception. We were staring at the skin of the universe, blind to the skeleton that lay just beneath. To pierce this veil, to give our flat map its missing dimension, we needed more than just light. We needed to interpret its very character. The key had been hiding in plain sight for decades, a curious property of a light first understood in the roar of an approaching train. Just as the pitch of a siren rises as it speeds toward you and falls as it recedes, light does something similar. Its wavelength stretches, shifting toward the red end of the spectrum as its source moves away from us. This phenomenon, the cosmological redshift, had been the bedrock of our understanding of an expanding universe. It proved that distant galaxies were all rushing away. But its true power lay dormant, waiting to be unleashed not as a philosophical tool, but as a practical cosmic measuring tape. By meticulously capturing the light from a galaxy and measuring the precise degree of its redshift, we could calculate its recession velocity. And because the universe expands at a known rate, that velocity could be translated directly into something we had never been able to grasp before: distance. Suddenly we had depth. The technical challenge was immense, requiring years of painstaking work, dedicating powerful telescopes for hours, even nights, to capture the faint, smeared-out light of a single distant galaxy. Each observation was a monumental effort to add just one more data point, one more anchor in the cosmic ocean. But as the first redshift surveys, like the groundbreaking work at the Harvard-Smithsonian Center for Astrophysics, began to populate our charts, a new universe began to snap into focus before our very eyes. The flat tapestry crumpled, folding into breathtaking structures of impossible scale. The points of light on our old maps were lifted off the page, assigned a coordinate in three-dimensional space, and the result was an absolute shock to the system. It was a revelation so profound it completely overturned a century of cosmological thinking. The universe was not a random scattering of island clusters. It was not a uniform mist of galaxies. It was something else entirely, something structured, something interconnected, something alive. As we plotted the points galaxy by galaxy, they refused to sit in isolation. Instead, they began to trace out unimaginable shapes. They formed colossal chains and delicate thread-like filaments of galaxies stretching for hundreds of millions of light years, a ghostly, luminous lacework spanning the darkness. These filaments converged on dense, tangled knots, the great clusters we already knew, which now appeared not as lonely islands, but as bustling cosmic interchanges where the great highways of the universe met. And connecting everything, surrounding everything, were voids of a truly terrifying emptiness. These were not mere gaps between the clusters. They were vast spherical deserts of space-time hundreds of millions of light-years across, in which almost nothing existed. Our universe, it turned out, was built like a sponge, or perhaps more accurately, like the neural network of a gargantuan brain. We gave this astonishing structure a name that was both simple and evocative: the cosmic web. This discovery was a paradigm shift in our understanding of cosmic organization. The neat hierarchical ladder we'd constructed was revealed to be a gross oversimplification. There was a higher order of architecture, a ghostly scaffolding upon which all visible matter was hung. The gravity of this invisible framework, woven from dark matter, had acted as the celestial shepherd for billions of years, funneling primordial gas along its filaments to form the galaxies we see today. The galaxies and clusters were not the masters of their own destiny. They were merely the brilliant froth on a much deeper, unseen gravitational ocean. Our own Milky Way was not an island, but a single house, on a single street, in a city that was part of a sprawling filamentary state, connected to a continental network of other states. The boundaries we'd so carefully drawn on our old maps dissolved into irrelevance. Where did one structure end and another begin? The question itself seemed suddenly naive. The universe was not a collection of things. It was a single continuous interconnected entity. And just as this new, breathtakingly complex picture was settling in, the data began to reveal an even deeper and more perplexing mystery. Our 3D map was a static snapshot, a single frame from a cosmic movie 13 billion years long. But the universe is a dynamic, evolving place. Everything in it moves. We had long understood the primary motion, the overall expansion of space itself, the Hubble flow, which carries all galaxies away from all other galaxies like raisins in a rising loaf of bread. But once we could measure distances with precision, we could finally subtract this universal expansion from our observations. What was left over was a galaxy's peculiar velocity, its own private motion, as it responds to the gravitational nudges of its immediate neighbours. We expected these peculiar velocities to be small, and most importantly random. A galaxy might be falling toward a massive neighbour here, or orbiting a small companion there, but on the whole, these movements should have averaged out to zero. They were supposed to be nothing more than local noise on top of the majestic uniform expansion. They were not. When astronomers began mapping these peculiar velocities, the true dynamic nature of our cosmic neighbourhood revealed itself, and it was utterly bewildering. Across vast swaths of the sky, they found that galaxies were not moving randomly at all. Entire groups, entire clusters, even clusters of clusters were all moving together in unison. They were locked into vast coherent flows streaming through space at hundreds of kilometers per second. It was as if we were looking down at a colossal river system. We saw tributaries of galaxies merging into wider streams, all flowing in a single overarching direction. This was not the gentle uniform expansion of the Hubble flow. This was a separate, powerful and directed motion, an immense gravitational undertow pulling on a scale that defied all explanation. Our own local group of galaxies, including the Milky Way, Andromeda, and dozens of smaller companions, was caught in this current. You and I are right now hurtling through intergalactic space at over 600 kilometers per second, more than 2 million kilometers per hour toward a destination we cannot see. The implications were staggering. The established models of cosmic structure, even the newly discovered cosmic web, could not account for this. The visible matter in the direction of the flow, the galaxies and clusters we could see along that filament of the web, was simply not massive enough to exert such a commanding gravitational pull. It was like seeing a fleet of ocean liners all turning in perfect formation, their engines cold, being pulled by a current with no apparent source. The gravity of the known structures was a gentle breeze. This was a hurricane. The coherent motion of so many thousands of galaxies spread across a region of space more than 300 million light-years in diameter demanded the presence of something else, something far larger, something gravitationally dominant. A hidden concentration of mass of almost unimaginable proportions lurking just over our cosmic horizon, its gravitational influence propagating across the void and taking hold of everything in its path. This discovery marked a critical turning point. It was the moment we realized that simply mapping the visible universe was not enough. The glowing galaxies of the cosmic web, it seemed, were only part of the story, perhaps only the decorative lights on a far more massive and invisible architecture. The universe was not just a static structure, it was a dynamic system of gravitational basins and watersheds. And we were not passive observers. We were residents living inside one of these watersheds, caught in a powerful cosmic river being pulled toward an unknown gravitational anomaly. The hierarchical view of the cosmos, already challenged by the discovery of the web, was now completely shattered. The forces shaping our destiny were not local. They weren't even regional. They were transcontinental, dictated by structures so immense they had eluded our grandest surveys. The map we had just begun to create was already telling us that its most important feature was missing a great continent of mass that was still shrouded in shadow. The hunt was on not just to chart the stars, but to find the unseen masters of the cosmic flow. We had to find the source of the river. We had to find what was pulling us. And so the mapmakers of the 21st century faced a challenge that would have humbled Magellan. They stood on the shores of a cosmic ocean, knowing their charts were fundamentally incomplete. The maps they had meticulously assembled from decades of redshift surveys showed islands of matter galaxies clustered into archipelagos separated by vast dark seas. We had named the prominent features like our own local island chain the Virgo Supercluster. Yet these maps only showed position a static snapshot in 3 dimensions. They were like maps of Earth that showed the continents but omitted the ocean's currents, the trade winds, the planet's very rotation. They captured where things were, but they failed to explain the most profound truth of our cosmic neighbourhood. Everything was in motion. The Great Attractor, that mysterious gravitational anomaly lurking behind the dust of the Milky Way, was proof. It was the ghost in the machine, a powerful unseen engine pulling us, pulling Virgo, pulling countless galaxies toward a destination we simply could not pinpoint. We were being swept along by an invisible river, yet we had no map of its banks or its ultimate destination. The very definition of a cosmic structure was in question. Was a supercluster just a region of higher density, a place where galaxies happened to be more crowded, or was it something more, something dynamic and unified, defined not by proximity, but by a shared fate? To answer that question, science needed a revolution. It required a fundamental shift in perspective, a new kind of celestial cartography. The challenge was no longer just to ask, where are we? But to ask a much deeper question, where are we going? The breakthrough came not from a more powerful telescope, but from a more powerful idea. A team of astronomers led by Brent Tully at the University of Hawaii and Hélène Courtois in France proposed a radical new way to draw the lines on the cosmic map. Instead of connecting the dots of light, they decided to follow the lines of force. They would map the universe not as a collection of objects, but as a dynamic field of gravity. Their insight was as simple as it was profound. In the universe, gravity is destiny. If you can map the gravitational landscape, you can understand the motion of everything within it. You can see the cosmic mountains from which galaxies flow and the deep valleys into which they will inevitably fall. This meant looking past the dominant motion of the universe, the Hubble expansion, that relentless uniform stretching of space-time that carries all distant galaxies away from us. For decades, this expansion was the foundation of cosmology, the large-scale wind at our backs. But hidden within this grand outward rush were subtler, more intimate movements. These are what astronomers call peculiar velocities. A peculiar velocity is the motion of a galaxy that deviates from the smooth cosmic expansion. It's the local eddy in the universal stream, the cross-current caused by the gravitational pull of nearby matter. If the Hubble expansion is a powerful outgoing tide, then peculiar velocities are the individual currents pulling boats toward nearby islands and unseen reefs. And it was these subtle, peculiar motions that held the key. Each one was a tiny arrow, a vector pointing toward the local center of mass. A single galaxy's peculiar velocity might seem random, a piece of cosmic noise. But if you could measure the peculiar velocities of thousands of galaxies of tens of thousands, of them, a pattern would have to emerge. The noise would resolve into a signal. The random arrows would align, revealing the invisible gravitational rivers, streams and torrents that govern the local universe. You could in essence watch the cosmos flow. This was a monumental undertaking demanding a data set of galactic motions more comprehensive than any ever assembled. It required scouring decades of astronomical surveys, gathering precise distance measurements and redshift data for galaxies near and far. Each galaxy needed 2 measurements: its redshift, telling us how fast it's moving away from us in total, and an independent, painstakingly acquired distance measurement. The difference between the two reveals the peculiar velocity, that crucial whisper of local gravity against the roar of cosmic expansion. The team compiled a catalogue they called Cosmic Flows 2, a census of over 8,000 galaxies in our cosmic vicinity. Each entry was more than a point on a map. It was a testament to a galaxy's journey, a data point tracing its gravitational allegiance. But even with this vast library of motion, the raw data was messy. The universe is a chaotic place, and teasing out the large-scale flows from the noisy individual movements of galaxies was like trying to map the Amazon basin by observing a handful of drifting leaves. They needed a tool, a mathematical lens powerful enough to filter the chaos and reveal the underlying structure. They found it in a sophisticated statistical method known as Wiener filtering. Originally developed to clarify noisy radio signals during World War II, this algorithm was now being repurposed for the grandest possible stage. Its function was elegant to separate the signal from the noise. For the Cosmic Flows team, the signal was the coherent large-scale flow of galaxies generated by the immense structures of dark matter and luminous matter. The noise was the smaller random motions and the inevitable uncertainties in their measurements. You can imagine it like this picture yourself in a helicopter high above a vast mist-shrouded landscape at night. All you can see are thousands of tiny flickering lights, each one a car on an invisible road. Each car is moving, but their individual paths are erratic. The Wiener filter is a computational miracle. It processes the movement of every single light, calculates the probable trajectory of each one, and subtracts the random swerves and jitters. Slowly, as the algorithm runs, a ghostly image begins to form out of the mist. You start to see not just cars, but highways. You see turnpikes and interchanges, boulevards and back roads. You see the entire hidden transportation grid that guides the flow of traffic. The astronomers were doing precisely this, but their flickering lights were entire galaxies, and the invisible highways were the gravitational filaments of the cosmic web. For months, supercomputers at the University of Lyon churned through the Cosmic Flows 2 data. The algorithms sifted, sorted, and reconstructed the three-dimensional velocity field of our corner of the universe. They were building a new kind of map, one not of static points, but of dynamic vectors and streamlines. Slowly, painstakingly, pixel by pixel, the program began to trace the paths of gravitational flow. It was a process of digital revelation, the universe itself whispering the secrets of its own architecture into the heart of a machine. And then they saw it. Emerging from the static of computational noise was a shape. It wasn't a cluster. It wasn't a wall or a filament in the way they had previously been understood. It was something else, entirely, something coherent and breathtakingly vast. The image that materialized on their screens was a map of a single immense gravitational basin, a cosmic watershed. It showed countless streams of galaxies, small groups flowing together to form larger rivers, all merging and converging, all inexorably drawn downstream toward a single deep gravitational valley. It was as if they had been given a god's-eye view of the continent on which we live, and for the first time they could see all the rivers flowing to the same sea. This structure was colossal, spanning more than 500 million light-years from one edge to the other. It contained the mass of 100 quadrillion suns. And within its gravitational embrace it held 100,000 galaxies, including our own. Our Milky Way, which we once thought of as the entirety of creation, was a single speck of dust in this magnificent flowing structure. The Virgo Supercluster, which for decades we had considered our home, was revealed to be just a provincial suburb, a minor tributary, feeding into a much greater cosmic river. Even the Great Attractor, the object of so much mystery, finally found its place. It was not some strange, isolated anomaly. It was simply the centre of the basin. It was the lowest point in our local gravitational valley, the place where all the rivers of galactic motion meet a cosmic drain, toward which our entire half-billion light-year neighbourhood is slowly and inexorably sliding. This was not a structure defined by density alone. Many of the galaxies within its boundaries are incredibly far apart, separated by yawning voids. What united them was not their proximity, but their shared gravitational destiny. They were all part of the same system, all going with the flow. A galaxy on the far side of this structure, 500 million light-years away, a galaxy we will never see up close, is our compatriot. It shares our cosmic home because it, like us, is falling toward the Great Attractor. This was a new address for humanity, a new identity. The team needed a name for it, something worthy of its scale and significance. They drew inspiration from their own location in Hawaii, a place where ancient Polynesian navigators charted the vast Pacific by observing the currents and the stars. They chose the Hawaiian name Laniakea. It means immeasurable heaven. Immeasurable because its scale defies human comprehension. Heaven because it is the magnificent luminous home that contains everything we have ever known. The revelation of Laniakea was a seismic shift in our understanding. Looking at the map, we could finally see our true place in the universe with shocking clarity. The structure is not a sphere. It is organic filamentary, almost alive. It looks like a delicate network of glowing threads and tendrils, all being pulled inward. Great rivers of galaxies, like the Perseus-Pisces Supercluster, form one of its mighty banks. The Pavo-Indus filament forms another, and our own galaxy, the Milky Way. We are not in the bustling centre. We are not even on one of the main thoroughfares. We find ourselves on a small quiet tributary, an outer branch of the Virgo Supercluster, which itself is on the periphery of the main flow. We live in the cosmic equivalent of the rural countryside, drifting slowly along a celestial backwater toward the great metropolitan basin of the Great Attractor. This new map resolved a long-standing paradox. The Virgo Supercluster had always been a problematic definition. It was a noticeable clump of galaxies, but its gravitational boundaries were fuzzy, its influence uncertain. Laniakea provided the definitive answer. The Virgo Supercluster has no independent identity. It is simply a lobe, a feature within the larger gravitationally bound entity of Laniakea. We live inside Laniakea in the same way someone lives inside a country which is itself part of a continent. The discovery also redefined the very concept of a supercluster. Prior to this, the term was a loose descriptor for a large collection of galaxies. Now it had a new precise physical definition. A supercluster is a region of space where all the peculiar velocities, all the internal motions are directed inward toward a common centre of gravity. It is a basin of attraction. If you were to place a new galaxy anywhere within Laniakea's boundaries, its fate would be sealed. Despite the universe's overall expansion trying to pull it away, the collective gravity of Laniakea's 100 quadrillion solar masses would eventually win. It would halt its outward journey and begin the long, slow fall inward. Conversely, just across Laniakea's border, the situation reverses. There lies a gravitational divide, a cosmic mountain range. A galaxy placed just on the other side of that line will flow in the opposite direction, drawn into the basin of a neighbouring supercluster like the immense Perseus-Pisces or Shapley superclusters. These boundaries are not walls. They are lines on a map of motion, as invisible and as real as the watershed that separates the Mississippi River basin from the rivers that flow to the Atlantic. For the first time, we had a name and a shape for the grand structure we belong to. We are all citizens of Laniakea. Every star you see in the night sky, every neighbouring galaxy like Andromeda, every member of our local group and the Virgo cluster beyond all, are passengers on this immense flowing vessel. This discovery transformed our cosmic address from a vague, ill-defined region into a coherent, dynamic home with a name that sings of poetry and scale. It is a place both immeasurably vast and deeply personal, for it is the largest gravitationally bound structure we can truly call our own. But this profound revelation did not close the book on cosmic cartography. Instead, it opened a new, even more tantalizing chapter. For the map of Laniakea in all its glory showed something else. The entire structure, this behemoth of 100,000 galaxies, is itself in motion. Our immeasurable heaven is not stationary. The entire watershed, from its outermost streams to its central basin at the Great Attractor, is moving as one. It is being pulled irresistibly across the universe towards something else, something even larger. The discovery of our home was at the same moment the discovery that our home was on a voyage toward an unknown shore. We had finally mapped our island only to realize that the entire island was adrift on an even greater, more powerful current. The question was no longer just where are we going, it had become where are we all going? And so with a single elegant stroke of cosmic cartography, our universe had been redrawn. The old maps, those comfortable constellations of galaxy clusters scattered like jewels on black velvet, were rendered obsolete. In their place stood a new reality, one defined not by what you could see, but by where you were going. Laniakea was not a place but a process, not a thing but a flow. This revolutionary idea, this gravitational watershed we now called home, was a moment of profound clarity. But like all great revelations in science, its brilliant light cast long and perplexing shadows. For every question it answered, it unearthed a dozen more, each deeper and more challenging than the last. The beautiful flowing map, while providing a sense of belonging, also introduced a terrifying new ambiguity. With this new understanding, the very concept of a cosmic border became fluid, almost poetic. Before we imagined superclusters as islands of matter in a sea of void, their edges defined by a simple drop-off in the density of galaxies. It was a tidy, reassuring picture. But the Laniakea definition washed that simplicity away. If our home is a basin of gravitational attraction, then its edge is not a cliff but a mountain ridge, a divide in the truest sense of the word. Picture yourself standing on that cosmic ridgeline. To one side, every speck of dust, every star, every galaxy feels the inexorable pull toward Laniakea's heart. But shift your position by a single light year, and you have crossed an invisible threshold. Now the gravitational tide has turned pulling you toward the neighbouring supercluster Perseus Pisces, or perhaps Shapley. There is no wall here, no signpost declaring you are now leaving Laniakea. There is only a zone of exquisite gravitational balance, a place of cosmic neutrality, where the universe itself seems to hold its breath, uncertain of which way to fall. This fuzziness, this lack of hard edges, created a firestorm of debate among cosmologists. How do you measure a thing that has no definitive boundary? How do you weigh a structure whose outermost members might with a slight nudge abandon it for a rival? Our own Milky Way, once thought to be a resident of the Virgo supercluster, was now revealed to be just one of 100,000 galaxies, on a pilgrimage, a small vessel swept up in a celestial current of unimaginable scale. We were no longer island dwellers but riverfarers. This shift in perspective forced us to see our neighbours not as distant strangers, but as fellow travellers, or even as gravitational competitors. The Perseus Pisces supercluster, once a separate entity on the map, now became our great rival, a colossal basin of attraction pressing against our own, its gravitational tendrils wrestling with Laniakea's for control of the galaxies caught in the borderlands between them. The universe, it turned out, was not a static museum of objects, but a dynamic, fluid battleground of gravitational influence, and we were living right in the middle of it. The lines on our new map were not permanent ink. They were shifting currents in a celestial ocean, and understanding their ebb and flow became the next great challenge. Yet for all the complexity this new vision introduced at its periphery, the most profound mystery lay not at its edges but at its very core. Every watershed by definition must flow downhill. Every river has a destination, a final basin into which it empties. For the 100,000 galaxies of Laniakea, including our own, that destination has a name one whispered for decades, with a mixture of scientific reverence and frustration, the Great Attractor. It is the gravitational centre of our world, the point of convergence for this immense cosmic flow. For billions of years, the Milky Way has been hurtling towards this unseen point in the sky at a staggering 2 million kilometres per hour. We are falling, and we have always been falling toward this gravitational behemoth. The very discovery of Laniakea was in essence the act of finally mapping the full extent of this titanic entity's sphere of influence. We had finally drawn the borders of its kingdom, but here is the maddening, almost cruel cosmic irony. Now that we had identified this central point, this anchor for our entire supercluster, we found we could not see it. We had mapped the river, but its destination remained shrouded in fog. At the very heart of this magnificent structure in the direction of the constellations Norma and Centaurus lies the one place in the sky we are fundamentally blind to. The reason for this blindness is not some exotic, universe-altering phenomenon. It is something far more mundane and far more frustrating. We are trying to look through the clutter of our own home. Our line of sight to the Great Attractor is blocked by the densest part of our own Milky Way galaxy. This obstructive band stretching across our night sky is known as the zone of avoidance. It is not a zone of emptiness, but the opposite, a region so choked with stars, so thick with interstellar dust and gas that it forms an almost opaque veil, a celestial curtain that conceals a staggering portion of the universe beyond. Imagine trying to study a distant mountain range, but your house is situated in the middle of a dense, blindingly lit city. The glow and smog of your immediate surroundings would wash out any faint light from the peaks beyond. For astronomers, this is our reality. The billions of stars in our galaxy's disk create a foreground glare of unimaginable intensity. Worse still are the vast dark clouds of cosmic dust. These clouds don't just dim the light from distant objects, they absorb it entirely, particularly at visible wavelengths, rendering entire swathes of the cosmos completely invisible to traditional telescopes. We are in a very real sense living inside our own blind spot. For centuries, astronomers simply avoided this zone, focusing their instruments on the clearer skies above and below the galactic plane. But now this once ignored patch of sky held the key to understanding our place in the universe. The gravitational heart of our supercluster was hidden behind our own galactic furniture, a cosmic puzzle of the highest order. This forced humanity's cosmic detectives to adopt entirely new methods. If you cannot see something directly, you must deduce its presence from its influence on everything around it. This is the art of gravitational forensics. Astronomers began meticulously charting the peculiar velocities of thousands of nearby galaxies. In a perfectly uniform expanding universe, as predicted by Hubble's law, all galaxies should be receding from us in a predictable way, with their speed proportional to their distance. But that is not what we see. All across our local cosmic neighbourhood, galaxies are deviating from this simple expansion. They are being pulled, nudged, and accelerated in ways that the visible matter alone cannot explain. And when you map these deviations, these gravitational anomalies, a stunning pattern emerges. They all point in the same direction, a great coordinated stampede of galaxies, all streaming towards that same obscured spot behind the Milky Way's disk. It was like watching leaves on a pond all being pulled toward an invisible drain hidden beneath the surface. You cannot see the drain itself, but its effects are undeniable, written in the motion of everything you can see. The sheer scale of this motion was breathtaking. It wasn't just a few local galaxies, it was a vast cosmic current spanning over 300 million light-years. This was the irrefutable proof, the gravitational smoking gun. Something was back there. Something with the gravitational pull of 10 quadrillion suns, a mass almost impossible to conceive, was reeling us in. The challenge for scientists was no longer to prove its existence, but to determine its nature. What could possibly command such gravitational authority? What kind of monster lurked behind the veil? The first attempts to pierce this veil were like tapping on a wall in the dark, hoping to discern what lay on the other side. Astronomers turned away from optical telescopes which were useless against the dust, and looked to other wavelengths of light. Radio telescopes, with their ability to detect the faint hiss of cold hydrogen gas, began to sketch the crude outlines of galaxies previously hidden. Infrared surveys, particularly from space-based telescopes like the Spitzer and WISE observatories, could peer through the dust with greater clarity, revealing the warm glow of countless stars in forgotten galaxies. These infrared eyes began to populate the zone of avoidance, turning it from a blank space on the map into a rich tapestry of stellar systems. X-ray telescopes, meanwhile, search for the superheated gas that signals the presence of massive galaxy clusters, the true heavyweights of the universe. Slowly, painstakingly, a picture began to form. Like archaeologists dusting off a buried city, astronomers uncovered a massive concentration of galaxies right where the gravitational anomaly was strongest. This sprawling collection, known as the Norma Cluster, is one of the most massive clusters in our local universe. It was a major discovery, a significant piece of the puzzle. Here it seemed was the culprit. But as the data improved and the mass of the Norma Cluster was more accurately calculated, a new problem emerged. It was massive, yes, but it was not massive enough. The Norma Cluster could only account for a fraction of the total gravitational pull that we measure. It was like finding a large rock at the bottom of the invisible drain, only to realize the suction is far too strong to be caused by that rock alone. The Great Attractor was not simply the Norma Cluster, it was something more. This realization deepened the mystery profoundly. The Great Attractor wasn't a single monolithic object, but a more complex and sprawling region of overdensity. It is a gravitational basin composed not just of the Norma Cluster, but likely also of other smaller clusters, vast filaments of dark matter, and thousands of individual galaxies all congregating at this cosmic crossroads. This makes its true nature even more difficult to untangle. We're not looking for a single gravitational point source, but for a diffuse continent-sized region of enhanced gravity, its various components all hidden from us at different depths behind the galactic fog. We're trying to weigh a ghost whose form we can only guess at from the ripples it creates in the space-time around it. The implications of this are staggering. We live in a structure defined by its gravitational heart, yet that heart remains an enigma. We know we are falling, but we cannot be entirely certain what we are falling into. Is it a chaotic confluence of matter? A cosmic pile-up at the intersection of several great filaments of the cosmic web? Or does it point to an even larger, more distant structure with the Great Attractor merely acting as a gravitational way station, on a journey to something even more immense like the Shapley Supercluster, another gargantuan concentration of galaxies that lies beyond it? The questions cascade, each one more fundamental than the last. The quest to unveil the Great Attractor has become one of the central dramas in modern cosmology. It is a direct confrontation with our own limitations, a battle fought with ingenuity and perseverance against our own obscured perspective. To truly understand our home, we must first understand its heart, and to do that, we have to find a way to pull back that final, frustrating curtain. We have to survey the contents of our own basement before we can claim to comprehend the architecture of the house. This pursuit pushes our technology to its absolute limits, forcing us to devise clever new ways to see the invisible. But more than that, it forces us to confront the very nature of the universe's primary building material, the substance that provides most of this gravitational pull, yet emits no light at all. For the story of the Great Attractor is not just a story of visible galaxies. It is inextricably linked with the greatest mystery of all, the pervasive invisible scaffold of dark matter that dictates the fate of everything we can see. To solve the riddle of our local gravitational anchor, we must first grapple with the dark foundations of the cosmos itself, and so, with the celestial cartography, complete the boundaries of our home supercluster, finally drawn by the invisible ink of gravity. We are left staring at the heart of the matter. We have given our home a name, Laniakea, but this new understanding does not dispel the shadows. Instead, it gathers them into one profound, concentrated mystery, a place on the map marked with the ancient warning, "Here be dragons." For at the very centre of this immense gravitational basin toward which we, and 100,000 other galaxies are inexorably flowing, lies the enigma that started it all, the Great Attractor. It remains a ghost in the machine, a cosmic puppeteer whose strings we can feel but whose form we cannot fully see. It resides in the most frustrating possible location in our sky, directly behind the cluttered star-choked plain of our own Milky Way galaxy. This dense band of stars, gas and interstellar dust, so beautiful to our eyes on a clear night, becomes a galling celestial blindfold for our most powerful telescopes. It creates what astronomers call the zone of obscuration, a thick curtain of our own making that veils a significant portion of the universe beyond. Visible light, the primary medium through which we have learned almost everything we know about the cosmos, is scattered and absorbed by this galactic smog. It is an act of cosmic irony so perfect it feels intentional. The very galaxy that gives us a platform from which to observe the universe conspires to hide its most significant local feature. Trying to see the Great Attractor in optical light is like attempting to view a distant mountain range through a blizzard raging just outside your window. The light from those distant galactic shores simply cannot complete the journey to our eyes. For decades, this left astronomers in a state of profound uncertainty. They could measure the pull, calculate its strength, and triangulate its position with remarkable precision. They knew something with the gravitational heft of tens of thousands of Milky Ways had to be there. But the direct, irrefutable photographic evidence remained tantalizingly out of reach, fueling speculation and debate. Was it a single, monstrously large galaxy cluster, an undiscovered behemoth of cosmic history? Or was it a more complex, diffuse arrangement of multiple clusters, their combined gravity creating this focal point? To pierce this veil, we had to learn to see the universe in different colours, to utilise forms of light that are immune to the fog of our own galaxy. Radio waves, with their long, lazy wavelengths, can navigate the dust lanes of the Milky Way with ease, slipping through the gaps between particles that would ensnare a visible light photon. X-ray telescopes, for their part, can detect the superheated gas that pools in the immense gravitational wells of galaxy clusters, glowing at millions of degrees. These alternate visions began to sketch the ghost's outline. They revealed not a single monolithic object, but a sprawling concentration of galaxies dominated by the Norma cluster itself, a massive celestial city. Yet even with these tools, the picture remains incomplete, like a charcoal sketch of a subject shrouded in mist. The full mass, the complete sensors of galaxies caught in that gravitational nexus, is still a matter of inference rather than direct observation. The core of the mystery, the very bottom of Laniakea's gravitational valley, remains partially obscured. But here is where the profound genius of the Laniakea discovery truly reveals itself. The new definition of our supercluster shifts our perspective so fundamentally that seeing the Great Attractor directly is no longer the most important piece of the puzzle. The mystery of the Great Attractor was born from a question of motion. Why are we moving in a way that Hubble's law of uniform expansion cannot explain? The concept of Laniakea is the answer. It reframes the entire problem. We are not being pulled by a singular mysterious object. We are participating in a vast, coherent and perfectly natural flow. Imagine yourself on a small raft in a river at night. You feel a persistent current pulling you downstream, but the darkness and fog prevent you from seeing the powerful waterfall or rapids you are heading towards. You might obsess over what that destination is trying to hear it to sense its shape in the dark. But a wiser approach would be to study the river itself. By mapping the currents around you, by observing how other rafts and debris move, you can define the entire river system, understand its banks, its tributaries, and its overall direction. You may never see the waterfall clearly, but by understanding the watershed, you understand your own motion within it completely. This is precisely what the definition of Laniakea accomplishes for cosmology. It is the map of the watershed. Our peculiar velocity, that 600 km per second sideways drift that so puzzled astronomers, is no longer a peculiar anomaly. Within the context of Laniakea, it is our local current. It is the expected predictable motion of a galaxy, following the gravitational contours of its home supercluster. The Great Attractor is simply the name we give to the deepest part of that valley, the basin toward which all cosmic rivers in our vicinity flow. The solution was not to find a single culprit, but to recognize that we were part of an enormous interconnected system. This conceptual breakthrough resolves decades of cosmological tension. It tells us that our galaxy's motion is not strange. Our previous map of the universe was simply too small. We were trying to understand the flow of the Mississippi River by looking only at a small creek in Minnesota. Laniakea provides the full continent-spanning context, and within that grand view, our journey makes perfect sense. We are not being dragged against our will. We are simply going with the flow, a gravitational flow that defines the very structure of our cosmic home. And with that realization, a new, even more profound perspective begins to emerge. If Laniakea is our gravitational continent, our cosmic watershed, then what lies beyond its borders? Is it an island in an empty sea? The answer unlocked by ever larger surveys of the universe is a breathtaking resounding. Our journey cannot end here because Laniakea itself is not a final destination. It is merely a single luminous node in a structure so vast, so intricate. It has been given a name that feels both biological and ethereal, the cosmic web. If you could zoom out far beyond the edges of Laniakea, hundreds of millions of light years away, you would witness the true architecture of the universe revealing itself. You would see that galaxies are not scattered randomly like dust motes in a sunbeam. Their distribution is not uniform. Instead, they are organized. They trace a colossal filamentary pattern, a glowing three-dimensional tapestry that permeates all of space. This cosmic web is the universe's hidden skeleton. It is a network of unimaginable scale, composed of immense thread-like structures called filaments, which connect dense hubs of matter. These hubs are the superclusters like our own Laniakea. The filaments themselves are cosmic highways, rivers of dark matter, along which galaxies flow from emptier regions toward these massive junctions. Where filaments intersect, the gravitational pull is strongest, and here you find the great galactic metropolises, the Coma Cluster, the Perseus Pisces Supercluster, and our own home. Connecting these bright nexuses are the long tenuous bridges of galaxies spanning the darkness like the strands of a spider's web, and in between these glowing filaments and nodes are the great voids. These are the vast empty deserts of the cosmos, immense bubbles of near-nothingness, hundreds of millions of light-years across. In these silent expanses, galaxies are exceptionally rare. The universe here is profoundly lonely. It is within these voids that the relentless push of dark energy, the mysterious force accelerating the expansion of the universe, holds the most sway, stretching the fabric of space-time and driving the cosmic web to become ever more defined. The formation of this incredible structure is a story of a cosmic battle fought over billions of years between two invisible titans, dark matter and dark energy. In the universe's infancy, dark matter, the unseen mass that outweighs all visible matter, by more than 5-to-1 began to clump together under its own gravity. It formed an invisible scaffolding, a gravitational blueprint for the universe we see today. Ordinary matter, the stuff of stars, planets, and ourselves, was then drawn into these dark matter halos, lighting up the skeleton and giving it visible form. This is why galaxies are not isolated islands. They are merely the brightest points, the glowing decorations on an immense underlying structure of dark matter. Gravity built the web, pulling matter together into filaments and clusters. At the same time, dark energy began to push, expanding the space between the filaments and evacuating the voids. The result is this beautiful cellular structure, a universe of dense interconnected highways and vast, silent emptiness. From this new vantage point, Laniakea loses its sense of ultimate centrality. It is no longer the entire world, but a single brilliant province in a global network. We can see our neighbours, other superclusters, not as distant and unrelated entities, but as connected nodes in the same grand design. To one side lies the Perseus-Pisces supercluster, another colossal filament of galaxies, a rival watershed to which we are gravitationally connected yet distinct. To another, the Coma supercluster, one of the first such structures ever identified, a dense and ancient city of galaxies. We are part of a cosmic community, a neighbourhood of superclusters, all tracing the same underlying architecture. And this realization brings us to the final dizzying layer of our cosmic address. Just as our galaxy moves within Laniakea, Laniakea itself is not stationary. The entire supercluster, all 100,000 galaxies bound in this shared gravitational destiny, is on a journey of its own across the cosmos. Our whole watershed is flowing toward an even larger, more distant gravitational basin. By looking far beyond Laniakea's borders, astronomers have identified an even more massive concentration of matter, a true titan, on the cosmic stage, the Shapley supercluster. Located some 650 million light-years away, Shapley is a behemoth, the most massive concentration of galaxies in our local cosmic neighbourhood. It exerts a subtle but unyielding gravitational pull on everything, for hundreds of millions of light-years around it, including our own Laniakea. The Great Attractor, the centre of our local flow, is itself just a passenger in a much grander current. Our entire supercluster is being gently but inexorably tugged toward the distant shores of the Shapley supercluster. It is a pilgrimage on a scale that defies all human comprehension, a motion within a motion within a motion. The Earth orbits the Sun orbits the Milky Way's centre, the Milky Way falls toward the Great Attractor, and the entire Laniakea supercluster is streaming towards Shapley. Every layer of our existence is defined by a state of perpetual nested motion, driven by the gravitational landscape of the cosmic web. But even this is not the full story. The dance of the cosmos is rarely so simple as a single pull. Recent, even more ambitious maps of the universe have revealed another crucial player in this gravitational drama. Just as matter clumps together to form superclusters, the evacuation of the voids creates regions of profoundly low density. These underdense regions exert an opposite effect, a gravitational push. While a supercluster pulls you in a void, effectively pushes you away as the galaxies on its far side pull more strongly than the sparse region nearby. Directly opposite the Shapley supercluster in our sky, astronomers have discovered one of the largest voids ever mapped, an immense ocean of emptiness. It has been aptly named the Dipole Repeller. This vast expanse of cosmic nothingness is effectively giving our local group of galaxies, and by extension, Laniakea, a gentle but persistent shove from behind. Our motion through the universe, therefore, is not a simple fall. It is a cosmic push-pull, a finely balanced choreography directed by the largest structures in existence. We are being pulled by the immense mass of the Shapley supercluster ahead of us, and pushed by the profound emptiness of the Dipole Repeller behind us. It is a discovery of breathtaking elegance. It reveals a universe that is not just a collection of objects, but a dynamic interconnected system where presence and absence are equally important. The filaments of the cosmic web guide our path, but the voids help to clear the way, creating a delicate interplay of forces that has charted our galaxy's course for billions of years. We live on a planet in a solar system, in a galaxy all flowing together through a supercluster that is itself a river in the sky, a river whose currents are dictated by the grandest mountains and valleys on the map of creation. The mystery that began with a strange stellar motion has led us here to an understanding of our place in the cosmic web, a single shimmering thread in an infinite loom. We are not merely observers of this grand tapestry. We are woven into its very fabric, each of us a transient pattern of stardust carried along on these silent gravitational tides. The finality we sought in defining our home has been replaced by the humbling realization that our home is and has always been on a journey without end. This new map does not show us a destination. It reveals the nature of the road itself, a path that stretches back to the dawn of time and forward into a future we are only just beginning to learn how to read. And so this cosmic ballet continues a silent, magnificent performance, choreographed on a stage 500 million light-years across. Each galaxy a pirouetting dancer, each cluster a grand ensemble, all moving in concert to the unheard music of gravity. To trace their steps, to follow their intricate paths, is to read a story written in the language of motion itself, a story that has led us on the most profound journey of all, the journey home. For millennia, home was the flickering light of a fire, the horizon of a valley, the shores of a familiar sea. Then it became the fragile blue marble of a planet, a precious sun-drenched island in an archipelago of worlds. We stretched our gaze further, and home expanded to encompass our star, a single luminous grain of sand on the shores of the Milky Way. For a time, this felt like the final frontier of belonging our city of 200 billion suns, a magnificent self-contained universe. But the story as we have seen did not end there. The faint fuzzy smudges in our telescopes resolved into other cities of light, other island universes, rushing away from us in the great cosmic expansion. We thought we were adrift in this expanding void, a solitary vessel. Yet as we learned to look past the light and listen to the pull, a different map began to emerge from the darkness. We detected a hidden current, a shared, peculiar motion that defied the simple outward rush of cosmic expansion. Our entire local group of galaxies, Andromeda, and our own Milky Way included, were not just coasting. We were being pulled inexorably towards the colossal congregation of the Virgo cluster. For decades, we defined ourselves by that landmark. We were residents of the Virgo Supercluster, a sprawling flattened metropolis with the gravitational weight of Virgo at its core. This was our new grander conception of home, a structure of immense scale. And yet even this was just a single province in a far greater kingdom. The map was still incomplete, the borders drawn in the wrong places. We were still mistaking a prominent mountain range for the entire continent. The true revelation, the one that redrew the boundaries of existence itself, came not from seeing more light, but from understanding the flow. By tracking the motion of 100,000 galaxies, we finally uncovered the invisible watershed of gravity, the gravitational basin that defines our ultimate cosmic address. This is Laniakea, Immeasurable Heaven. Not a structure you can see with your eyes, but one you feel with gravity. It is a dynamic living entity defined not by what it contains, but by the direction in which everything is flowing. Our Milky Way is but a single drop of water in a celestial river system, flowing from the quiet cosmic voids through the rapids of our local group and joining the great confluence of the Virgo cluster. All of it, every galaxy, every star, every atom you are made of is on a shared pilgrimage towards a single gravitational centre of gravity, a basin of attraction we call the Great Attractor. This is our home in the truest sense of the word, a collective of travellers bound by a common gravitational destiny. To grasp this is to fundamentally alter your perspective forever. When you look up at the night sky, you're no longer a passive observer looking out from a static platform. You're a participant hurtling through the cosmos at over 1 million miles an hour, a passenger on a vessel called the Milky Way, navigating the invisible currents of our supercluster. The ancient patterns of the constellations once thought to be fixed and eternal are revealed to be the view from a single window on this grand voyage. Our sense of place, Our very definition of here has been shattered and rebuilt on a scale that defies human intuition. It is a humbling and perhaps even terrifying realization, but it is also a magnificent one. It connects us to the universe in the most intimate way possible, tying our fate to the grand, sweeping narrative of cosmic structure. And yet in mapping this incredible celestial continent, we have come face to face with an even deeper mystery. The structure is there. The flows are undeniable. The map is drawn. But when we add up all the light, all the stars, the gas, the dust, everything we can see, touch and measure directly, we find it accounts for only a fraction of the mass required. The gravitational pull we are measuring, the very force that defines Laniakea, is overwhelmingly generated by something we cannot see at all. The visible universe, it turns out, is merely the foam on a vast dark ocean. The 100,000 galaxies we use to chart our home are just luminous traces like flecks of pollen on an invisible wind, revealing the shape of a force that dominates reality. This is the phantom architect of the cosmos, dark matter. It is the ghostly scaffolding upon which all visible structure is built. It was dark matter's gravity that in the early universe first began to corral the primordial hydrogen and helium, forming the dense gravitational wells where galaxies could be born. It is the invisible bedrock through which the rivers of Laniakea flow. Without it, galaxies would have flown apart, their stars flung into the void. Without it, clusters would have never formed. Without it, the entire cosmic web, this filigree of superclusters and voids, would be a featureless, undifferentiated soup. Laniakea itself, our home, would simply not exist. We know it is there. We have weighed its influence with breathtaking precision. We see its gravitational signature in the bending of starlight from distant quasars, a phenomenon known as gravitational lensing, where the invisible mass of dark matter acts like a cosmic telescope, distorting and magnifying the universe behind it. We see its effects in the rotation curves of galaxies, where stars on the outer edges move far too quickly, held in their orbits by a halo of unseen gravitational glue. We even see its presence in the leftover heat from the Big Bang, the cosmic microwave background, where its imprint is stamped onto the very first light of creation. We have mapped its ghost, but we have never caught it. The search for the nature of dark matter is one of the greatest scientific quests ever undertaken by our species. Deep underground in laboratories shielded from the cosmic rays that constantly bombard our planet's surface, scientists have built detectors of unimaginable sensitivity. They are vats of supercooled liquid xenon or germanium crystals designed to catch the faintest whisper of a collision, the ghost of a touch should a particle of dark matter happen to pass through the Earth and strike a single atomic nucleus. It is an experiment in cosmic patience, listening for a single pin drop in the midst of a cosmological hurricane. For years, these detectors have sat in perfect silent darkness waiting. Other scientists hunt for it indirectly, searching for the debris of dark matter particles annihilating each other. They point telescopes not at stars but at the dense hearts of galaxies like our own, where dark matter should be most concentrated. They are looking for an excess of high-energy gamma rays or other exotic particles, the faint death cries of a substance that otherwise lives in silence. At the Large Hadron Collider, physicists smash particles together at nearly the speed of light, attempting to forge dark matter in the laboratory to create for a fleeting instant the very stuff that holds our universe together. They search for energy that goes missing in the collisions, a sign that some new invisible particle has been created and slipped away unseen through their detectors. So far, the phantom remains elusive. It interacts with gravity, but seemingly with nothing else. It flows through your body, through the Earth, through the heart of the Sun, as if none of it were there. It is the ultimate cosmic irony. The overwhelming majority of the substance in our universe, the very foundation of our cosmic home, is utterly alien to us. We are residents in a house built by an invisible hand, following rules laid down by a substance we have yet to identify. The quest to understand dark matter is not just about solving a cosmological puzzle. It's about discovering the fundamental nature of our own reality. It is the search for the very soul of Laniakea. But even as we grapple with the mystery of the universe's missing mass, we have discovered another, perhaps even more profound enigma. Another invisible force working in direct opposition to gravity. While dark matter's gravity assembled the great structures like Laniakea, this other force is trying to tear them all apart. We call it dark energy, and it is winning. The discovery was a shock that rocked the foundations of cosmology. For most of the 20th century, the great debate was whether the universe contained enough mass to halt its own expansion. Would gravity eventually win out, pulling everything back together in a final fiery big crunch? Or would the expansion continue forever slowing, but never stopping, leading to a cold, dark and empty future? When two independent teams of astronomers set out to measure this deceleration, to find out just how much the universe was slowing down, they found the exact opposite of what they expected. The expansion of the universe is not slowing down at all, it is accelerating. Some unknown energy inherent in the very fabric of space-time itself is pushing everything apart. It is a gentle but relentless pressure, a cosmic anti-gravity that is growing more dominant with every passing moment. In the distant past, when the universe was smaller and denser, gravity was king. It had the upper hand, allowing it to pull matter together and build the magnificent cosmic web we see today. But as space expanded, the grip of gravity weakened while the repulsive force of dark energy, a property of space itself, grew stronger. A few billion years ago, the universe passed a cosmic tipping point. Dark energy took control. This discovery paints a new and rather lonely picture of our ultimate fate. The grand structures we see today, like our own Laniakea supercluster, are the last great works of gravity's fading empire. They are gravitationally bound islands, collections of matter, that managed to come together before dark energy grew too strong. Within these islands, gravity will continue to reign. The Milky Way and Andromeda will still merge in a few billion years. Our local group will remain tethered to the greater Virgo cluster. Laniakea, our home, will hold together as a single coherent structure. But everything beyond our shores is being pushed away from us faster and faster with every passing second. We are living in a precious, fleeting cosmic moment, a time when we can still see the light from other superclusters, other great continents on the cosmic ocean. But in the far future, as dark energy continues its relentless work, those distant structures will be pushed away so fast that their light will no longer be able to reach us. They will accelerate beyond our cosmic horizon, vanishing from view as if they had never existed at all. Future astronomers in our own supercluster looking out into the void will see nothing but an endless empty expanse. They will be trapped on a solitary island of light with no evidence that any other structures ever existed. The grand story of the universe, the cosmic web, the expanding cosmos itself will be lost to them forever. The great tapestry of the cosmos is fraying at the edges, and we are privileged to be the generation that gets to see it in all its magnificent interconnected glory before it dissolves into darkness. This realization infuses our quest with a profound sense of urgency. The maps we are making today are not just for us. They are a legacy for the deep future, and we are building new ships to chart these fading shores. The next generation of cosmic cartographers is already taking flight. Missions like the European Space Agency's Euclid telescope are designed to create the largest, most accurate 3D map of the universe ever made, observing billions of galaxies across 10 billion years of cosmic time. Its goal is to chart the history of the cosmic expansion and the growth of structure with unparalleled precision, allowing us to see the cosmic tug-of-war between dark matter and dark energy play out across eons. NASA's Nancy Grace Roman Space Telescope will join this quest with a field of view 100 times wider than Hubble's. It will conduct a grand census of the cosmos, discovering thousands of new supernovae to measure the effects of dark energy and mapping the distribution of dark matter through gravitational lensing on an unprecedented scale. On the ground, the Vera C. Rubin Observatory in Chile will survey the entire visible southern sky every few nights, producing a motion picture of the universe of stunning depth and detail. It will track billions of objects, charting their movements, their brightness, their history, creating a dataset so vast it will challenge our very ability to comprehend it. These are our modern-day equivalents of the great voyages of discovery. We're no longer just mapping our local waters. We're building the instruments to survey the entire ocean, to understand its currents, its depths, and its ultimate destiny. So we stand at the end of one journey of discovery and at the beginning of another. We have followed the gravitational breadcrumbs from our small planet out to the staggering scale of our supercluster home. In doing so, we have drawn a new circle of belonging around ourselves, one that encompasses 100,000 galaxies and stretches across 1/10 of the observable universe. We have learned that the universe is not a quiet, static place, but a dynamic, flowing and evolving entity shaped by invisible forces we're only just beginning to comprehend. Our address is not a point in space, but a path through space-time. Our home is not an object, but a process. And this perhaps is the most profound revelation of all. From this spinning Earth, in this unremarkable solar system, on the outskirts of an average spiral galaxy, a tiny collection of organised matter has awakened. We who are but a fleeting expression of this cosmos have somehow developed the capacity to look back upon it, to measure its breadth, to chart its currents, and to question its purpose. We are the universe made self-aware. We are the part of Laniakea that has learned to see itself. The journey is far from over. The greatest mysteries remain unsolved. But the quest, the unending, uniquely human desire to understand is the noblest voyage of them all. To seek to find and to comprehend our place within the immeasurable structures we are finally truly beginning to call home.